Welcome back. Today we're looking at question 1E from the 2018 MAT paper, and it goes like this. So we're told that a circle of radius 2 centered about the origin is drawn on a grid of points with integer coordinates. Let n be the number of grid points that lie within the circle, and we need to find out what is the smallest amount that the radius needs to be increased so that there are 2n minus 5 grid points in the circle, and we're given 5 different options. Okay, so this is our diagram for this question. We have a circle of radius 2 centered about the origin, and we've also got all the integer coordinates marked on by little x's. So these are the places where the coordinates are integer values, so 2, 0 for example. And remember, the first part of the question was to work out how many of these crosses lie within the circle or on the boundary, and that's just a matter of counting. So we've got 9 in this little square, and we've also got 4 on the boundary, which gives us a total of n equals 13 points. So that was the first part. And then the second part of the question was, how do we, by how much do we need to increase this circle, the radius of the circle, so that we have 2n minus 5 points inside? So this is just, we can calculate this as 2 times 13 minus 5, which comes out as 21. So to get from 13 to 21, we need to find an extra 8 points. So try and visualize what would this look like. We want a slightly bigger circle, so maybe it would look like this, and we want to find some extra points that lie within here, such that we have 21, so the minimum radius that we need to increase this by. And you can see that the closest points that are not already in the circle are these ones right here. And because of the symmetry of the plane, these points are equidistant from the origin. So the points I'm marking have coordinates plus or minus 1, plus or minus 2, or plus or minus 2, plus or minus 1. So you've also got 4 on this side, these ones right here. And conveniently, these are exactly 8 points that we need. So you can see that these are going to be the first coordinates we encounter if we increase this circle. We're going to hit these before these, for example. So we need to find the distance between the origin to one of these points. It's going to be the same distance. So let's just take this point right here, for example. So to calculate this is just Pythagoras. Let me just draw out the triangle again. So we have the origin here, this point, and we have this point right here. So this side is going to be 2 from the x coordinate, and the height is going to be 1. And then just using Pythagoras, this comes out as square roots of 2 squared plus 1 squared, which equals the square roots of 5. So that's the radius of the circle we need so that we have exactly 21 points lying within the circle or on the boundary. So that means that the answer to the question, we need to increase the radius by square root of 5 minus 2. Because the original circle already had 2, so if we just add on this value, we're going to have a radius that equals exactly the square root of 5.